Hello friends, last class I discussed about the KMF for the mean term or KMF for the sum of product. So in digital electronics, in Boolean expression, if you see that there are the two terms, one is the sum of product and another is the product of sum. This thing I have already discussed. Sum of product means suppose you have one function a B C plus A B prime C. So this is sum of product. So first we are doing product and then sum. So another function is the POS, right? This is SOP and another is the POS. A plus B plus C prime, A plus B plus D, like this way. Okay, so this is the product of sum. Product of sum. First we are doing sum and then product. Okay. So in the last class we discussed that how can you minimize this sum of product by using the K-map. Okay. So today I'll discuss about how can you minimize the product of such. Minimize the Boolean expression which is in the form of the product of sum. Okay. How can you minimize the product of sum expression using K-map. Okay. And there is one condition, that is don't care condition. How if you don't care condition is there in both expression, how can you minimize? Okay, so this I will discuss today, right? So first I am writing the truth table for three variable map. How, what will be the truth table if I write the product of sum expression? Okay, so product of sum is these are related to max term, and sum of product these are related to min term. Okay, so suppose here A B C, here my function. Okay, I am writing all the 8 combinations. Okay, here all the 8 combination I have written. So this I have already discussed. How can we represent the mean term and max term in truth table? Okay, max term is related to product of sum, right? So this max term is the M0, M1, M2, M3, M4, M5, M6, M7. Okay. So this I can again write as a, so 0 means A. Okay, if I am including A with a B, I am putting plus. Okay, here you can write as A plus B plus C prime. A plus B prime C. Okay, 1 means B prime. Okay, 1 means prime and 0 means not prime. Okay, you are including all the terms, that means plus and I am putting here. Okay, C prime. Okay, A prime B plus C. A prime B plus C prime. Okay, A prime plus B prime plus C. A prime plus B prime plus C prime. Okay, these are all max terms. Now, if we have if we have some max terms, okay, how can you minimize those max? How can you get the minimum expression by using the K-map? This I will discuss. Okay, so the K-map, the structure of the K-map, that will be little bit different for a POS function for this max term. Okay, so I will directly go to the four variable K-map. So this here I have written three variable truth table. How can you represent the three variable truth table in case of the max term? Okay, right. So suppose you have one function. Okay, 014, capital M 014. That means at 0 I have logic 0, at 1 I have M1 I have logic 0, at M4 I have logic 0. Okay, and all other cases I have 1. Okay. So when you deal with the max term, I have to deal with the only 0. Okay. So in KMF, I have to put only those 0. 1 I have not put. So mean term is if in a one function, if the 0, 1, 4 are the max term, that means other are the mean term. Okay. So mean term can be represented as a 1 and max term can be represented as a 0. Okay. So when we have the max term, so that means you have to minimize the max term using KMF. When you have to minimize the max term using the KMF, so I have to consider those max terms. That means in KMF I have to put logic 0 only, right? So just now I'll show you. Okay, so one expression I am writing f comma a comma b comma c comma d summation n. Okay, summation n 0, 1, 2, 4, 6, 8 and 9. Okay, this is one function. That means from the question I have to understand that this is related to four variable. Okay, a b c d's are there, right? And this is to four variable, and I have those max terms. That means I have the output 0 in those max terms. Okay, I have the output 0 in those max terms, right? So if my small m is mentioned, that means these are related to min terms. So I have my output 1 in those min terms. Okay. So when you have the max term, how can you minimize the max term by using the KMF? So first I am drawing the KMF structure is almost same, but there is some different. Okay. So as 4 variable means how many combinations? 2 to the power 4 is 16 combinations are there. So if you remember the last class, so 2 to the power 16 means I need 2 to the power total 16 cell. Okay. So here I am putting A, B, and here I am putting C, D. Okay. So normally here it is 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1, 0. Okay. The numbering will be like same one. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay. But here I used to write, if you remember, here I have written a 0, 0 means a prime b prime, like this I have written. 0, 1 means a prime b, like this I have written. But in case of the max term, the representation will be different. So 0, 0 means a. Okay, I am adding b, I am including b, so a plus b. So here a plus b prime. Here a prime plus b prime. 1, 1 means a prime plus b. Instead of dot, I am putting plus in case of the POS. Okay. And here a prime plus b. Okay, in this here I am writing c prime, c plus d. Here c plus d prime. Okay, here c prime plus d prime. Last one is the c prime plus d. Okay, so just 0 means here I am considering a, or 1 means a prime. Okay, in the POS, in the SOP KMF, 0 means a prime, and 1 means a, and dot means plus here. Here I am putting dot, here I am putting plus. Okay. Now what is the question? In those, these are the my max term. So in those cell I have to put logic 1 or logic 0. Sorry, logic 0. Okay. So 0, 0, 0, 0, 0, 0, 0. Okay, right? So you can see. So now grouping is same. Now grouping is same. Okay, that means we have seen in those condition I have mentioned logic 0 in those cells. Okay, now I have to do the grouping. Okay, so what I told, so grouping is same for the max term and the min term. Okay, first you have to check if any octal is there or not. Octal means total 8 adjacent zeros are there or not. So here I can say total adjacent 8 zeros are not present. Now come to the total adjacent 4 zeros are present or not. Okay, I can see. So outer cell, these are also adjacent. So this 2 0 and this 2 0 can create a one pair. Okay. Apart from this thing, any more four adjacent zeros are present or not. Okay. So now you can see, yes, these four zeros can create a one group. So how many groups are there? Two groups. These two, these four, and these four. Okay. Now I am writing the expression for first group. Okay. This is first group. This is second group. Okay, so my f is equal to, I am considering first group. So in four cells, which values are common? Okay, in these four cells, which values are common? If I see a b value, so you can say b is common. Okay, so b means b actually, 0 is common, 0 means b. I am writing B. Okay. I am including. So if you remember the previous KMF, so SOP KMF, if we include this term with this term, I am putting multiplication. Now here I want to include this constant term with this constant term. I have to put plus. Okay. Now plus. Okay. So here in these two cell I am checking which value is common. This 0 is common, right? This 0 means C. Okay. C. Right. Now here. So now if you want to include second group. So for a POS, I have mentioned the plus sign to include the and one more group. If here if you include the one more group, I have to put dot sign. Okay. Now I am checking for this cell which values are common. Okay. So here also I can see A is common, right? A. And in those side I can see D is common. 0 is common. This 0. Common 0 means D. Okay. So this is my minimum expression. So I have has now you can see here if you see 0, 1, 2, 4, 6, 8, 9. I have the total 1, 2, 3, 4, 5, 7 max terms. So from 7 max term I get 2 max term. D plus C, this is also 1 max term. Y plus D, this is also 1 max term. So from 7 max term I got only 2 max term. Right? Now, okay. Now if you have the one another condition for this is about the maximum. I hope all of them understand how can you minimize the maximum or POI by using the KMF. Now, if I see suppose some question is there for variable, okay, 2, 9, 12, 15, 3 plus D 1, 11, 13, 14. 1, 11, 13, 14. 2, 3, 9, 12, 15, 1, 11, 13, 14. Okay. Again, I am drawing the camera. So I am directly writing these things. Right? Okay. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 12, 13, 14, 15. Okay. So first I am putting these are my max terms. So that means I have to put logic 0 in those max terms, right? So first I am putting logic 0 in those max terms. Okay. Now come to the what it is. This D means don't care. Don't care. That means I don't know what is the value for those conditions. D means don't care. I don't know what is the value for those max terms. Okay, I don't know what is the value for those max terms. Either so in digital so you have the two values only. Either it is 0 or it is 1. Okay, that means I have to put logic. I have to put only x in those max terms or in those cells. I have to put x. That means x is maybe 1 or it may be 0. Okay, it is not there. 1, 11, 13, 14. Okay, now you can see x 0, 0 x 0. Now how to do paired? Okay, grouping. So for grouping, you have to include those don't care conditions. Okay, include those conditions. Right? Suppose along with any don't care, if you have 0. Okay, so that means for grouping of 0, I have to consider that don't care. Right, suppose and along with don't care, you have only don't care. So this grouping is not required, but along with don't care, you have zeros. So for grouping of 0, you have to group entire and don't care as well as the 0. Again, another mode, suppose you have and don't care and okay, such conditions are there. So in the along with this 0, you have 0 and you have don't care also. So if we include only 0, we can do the pairing. So we don't include this don't care. Okay, if only single 0, if any zeros are there, so for including those, for grouping, if we need don't care, we'll add. Okay, so for suppose here in this condition, we can say in this condition all are x, or no more x zeros are there, so this grouping is not required. This is not required. Now you can see this both x, these zeros are there, but so we cannot consider this don't care, but only this grouping is possible because this zero, both zero can do create a one group, but we have to do the maximum number of cells. We have to do the grouping for maximum number of cells. Okay, that's why I am taking quad. First I have to check octal, then pair, quad, then pair. Okay, so here I can see the quad is possible. Although we are considering x, but quad is possible. That's why I will take both x along with both zeros. But here you can see. So here also pair is possible, here is pair is possible, but I have to consider this pair. So x is not required to consider. Okay, these are the conditions. These are the things we have to mind. We have to remind when we do this kind of the when we want to solve this kind of the solution. Okay, now you can see. So here you can see only octal is possible. These four, these 2x and these 2 0 can create a one pair, and this. Here also two groups are there, right? So first I am writing, this is one group, this is two group. F I am writing, okay. So for here I can see, if we see this value, A prime plus B prime is constant for this four cell, okay. A prime plus B prime, okay. So if you see the vertical below, no values are constant for these four cell. Only these two values are constant for this. Okay, now come to the second group. So for including second group, I have to put dot. Okay. So if we see into second group, now you can see if we see the this value. Okay, this value, horizontal value, you can see B is constant, right? B. Again, if we see the that this value, okay. So here in these cases, d prime is constant. You can see d prime is constant, so it is d prime, right? So this is the minimized expression for this particular solution. Okay, now if we have the don't care for mean term, what will be the solution? If we have the don't care, suppose four variables are there, 1 5 6 12 13 14 plus d 4. Okay, so here you can see you have this is the my don't care condition. So how we will solve? Same thing, we have to do same conditions. You have to remember when we consider the don't care for grouping. Okay, okay. Now 0 1 2 3 4 5 6 7 8 9 10 11 12 13 15. Okay, so I'm putting logic on. Mean term means I have to put logic on in those cells. 1 1 1 1 1 1. Okay, and d4 is the don't care. Here I have to put x. Okay, right? Now how to do the grouping? Here also you can see I can see the quad. Okay, so you can see three ones are there, but along these three ones, okay, so individually this pair and this pair will not do. So here you can see quad is possible. Though you can see the don't care is present in the quad, but so if you include the don't care, we can do the quad. But first, that's why I have to first do the quad only. Okay, so if we include the don't care, I can go and create a quad. So that I have to consider, right? Next is the this one. Here also for making a second quad, if I include these two one and this don't care along with one, so this is also possible. Okay, so I have to first take maximum possible quad. Either it should include don't care or not, that I will not check. Okay, so so maximum possible quad. Now this one is left. For that I have to can take this one. Okay, I have to take this one, right? So what will be the function now? So first quad, okay, first quad, if you see this value b is constant, right? For this first quad, if you see this value c prime is constant. Now plus, for adding second group I have to put plus sign. So for this quad, for this quad I am taking this value again, b is constant. If I see the vertical value, d prime is constant. Okay, now this pair. So for this pair, if I see this value, a prime is constant, and if you see this value, c prime and d both are constant. Okay, so this is the expression for minimum for mean terms which has don't care. Okay, right? That means so first for case of the don't care, first we have to check the whether octal is possible or not. So in this octal, if don't care is present, then we can take don't care, right? And again we have to say check the quad is possible or not, right? So if all the zeros and ones are covered, okay, for me as a for MPOS or SOP respectively, so then if any more x is left, so we will not consider these x for grouping. Okay, so this is the conditions for grouping of x. Okay, so the KMF, how can you minimize the min terms and max term by using KMF? These topics are already covered. So one small topic I want to discuss. So sometimes you have to draw the logical diagram for the minimum expression. Okay, whatever minimum expression you are getting, you have to draw the logical diagram. Right. So suppose you have, okay, POS expression, again you have, okay, SOP expression, right? So if you have the POS expression, so normally the question is like the draw the logical circuit using basic gate and draw the logical circuit using universal gate. So we can see that NAND and NOR are universal gates. How can you design the basic gates using the universal gate that I have discussed in the previous lectures? Okay, so so that means sometimes questions will be like that. So design this minimize expression using universal gate. Okay, if POS expression is there, okay, normally in POS expression first, if you see the basic gate, if you see this expression, if you want to draw this expression by using basic gate, first you have to OR, do the OR and then AND. First you have to OR and then AND. Okay, here first you have to do and then OR. Okay. Now, if you want to use the basic gate for POS expression, you have to use mainly NOR gate. Okay, so minimum circuits are required if we implement POS expression by using the NOR gate. And for SOP expression, mainly NAND gate is required. Okay, if you choose the universal gate, NAND gate you have to choose for SOP expression. NOR gate you have to choose for POS expression for minimum number of gates. Okay, we can design this expression using NAND gate and this expression using NOR gate, but you need more number of gates. So with consideration of minimum gates, we have to choose the NOR gate for POS expression and NAND gate for SOP expression. Okay, so first I am implementing using NOR gate. First I am doing the basic gate implementation. Okay. Okay, now I have to implement, I have to replace all the basic gates with the NOR gate. Okay, so equivalent circuit. So on OR gate, how can you represent? If you want to replace the or NOR OR gate with NOR, you can see Along with one NOR gate I have to put, along with the NOR gate and one more NOR gate I have to put. Okay, in the same way. So OR gate equivalent, this is the OR gate. Okay, equivalent to this OR gate is, this is the NOR gate. Okay, so here also, now AND gate. So AND gate, what is the equivalent NOR gate for AND gate? So how we will do, first I am adding one NOR gate, here one NOR gate. In two terminals I am adding two NOR gates. Okay, and here I am adding, including one NOR gate, replacing this AND gate with the NOR gate. Okay, right? So that is what I did. So this I replaced with one NOR gate, and behind of this NOR gate I put one more NOR gate here also. And for AND gate, so in front of the AND gate I have mentioned two NOR gates, and they replace this AND gate with the NOR gate. Okay, now you can see here, these I can cancel. Why? Because this is have the same two consecutive NOR gates are there, and for two consecutive you have the single inputs. So you can cancel those NOR gates. Suppose you are getting X here. Okay, so here you will get X prime because one NOR gate is equivalent, one input NOR gate is equivalent to one NOT gate. Right. Again, if you do again operation here, X prime prime, that means it is also X. So here I am getting X and here also I am getting X. So you can remove these two gates. Okay, here also you can remove. So that means this circuit is equivalent to this circuit, right? So for three gates, again three NOR gates are required. So if you implement this circuit with the NAND gate, you need more number of NAND gates. Okay. Last is the this one. How can you implement this with the NAND gate? So again I am drawing basic gates. Here you get A, B, C, D. Okay. Right. So here NAND gate means here. So I am replacing this AND gate with the NAND gate and followed by one more NAND gate. Okay. Here also I am replacing this AND gate with the one NAND gate followed by one NAND gate. Now for OR gate. For OR gate, how can you replace OR gate with NAND gate? In front of OR gate, I have to put two more NAND gates. And this will be replaced by one NAND gate. Okay. Now here in also same case you see. So NOT gate, one NOT gate is equivalent to one single input NAND gate. Okay. Suppose if you have X here, you will get X prime here, you will get X prime prime here. That means it is also X. So you can cancel these gates. So if you have consecutive two NAND gates with a single input, you can cancel those AND gates. For those NAND gates. For NOR gate also, if you have this two consecutive NOR gates with a single inputs, you can cancel those NOR gates. Right? If you cancel, so you get this one. Right? This is the expression. So these are about the minimization of the gates using KMF, and how can you draw the minimum expression by using basic gates. So these lectures includes those topics. Okay, next class I will discuss about the one topic related to KMF only. This that the prime implicant, accession prime implicant. This I will discuss on next class. So kindly subscribe my channel and like and share. Thank you.